everyone, so today we will solve another topic of fluid mechanics, chapter 17, fluid flow in pipes from the book of Eunice and Jaljan Simbala, 8-52. So glycerin at 40 degrees Celsius with density of 1252 kg per cubic meter and the mu equals 0.27 kg per meter second is flowing through a 4 centimeter diameter horizontal smooth pipe with an average velocity of 3.5 meter per second. That determines the pressure drop per 10 meter of the pipe. So this will be our illustration. A pipe with a glycerin of 3.5 meter per second and the diameter 4 centimeter, the length 10 meter. So in our given, we have the glycerin at 40 degrees Celsius, a density of 1,252 kg per cubic meter, and the mu 0.27 kg per meter second, the diameter 0.4 centimeter, and the velocity 3.5 meter per second. So the formula we're going to use, we have the discharge flow rate equals area times the velocity, the Reynolds number, diameter, times the velocity, times the density over mu, and the friction factor, we have F equals 64 over the Reynolds number. So, our formula for the pressure drop is the same as getting the head loss. We have the friction factor times the length over diameter times the density times the velocity over 2. So checking our values, we don't have a value of friction factor in our given. So first, from the formula of the friction factor, we need first to get the Reynolds number. So in our solution for the discharge, V equals area times the velocity equals to volume flow rate pi d squared over 4 times the velocity. Plug in the value 3.14 times 0.04 meter squared over 4 times 3.5 meter per second. We will have 0.04396 cubic meter per second. Solving for the Reynolds number, we have the formula diameter times the velocity times the density over mu. So 0.04 meter times 3.5 meter per second times 1,252 kg per cubic meter over 0.27 kg per meter second. Plugging in using our calculator, we will get the Reynolds number 649.19. So, in solving the friction factor using the formula 64 over Reynolds number, or plug in 64 over 649.19 equals to 0.09859. So now we can solve for the formula of pressure drop. The change of pressure drop equals to friction force times the length over the diameter times the density v squared over 2. Plug in the value, we have the friction factor 0.09859 times the length 10 meter over the diameter 0.04 meter times 1,252 kg per cubic meter times 3.5 meter per second squared over 2. So using our calculator, we will get 189,009.35 convert it to kilopascal. So 1 kilonewton over 1000 kilogram meter per second square equals to 1 kilopascal over 1 kilonewton per meter squared. So we have this 189 kilopascal. This is the pressure drop per 10 meter of the pipe.